Let's dive into this explainer. Ever wonder how factories actually measure the pollution blasting out of those giant chimneys?
Sure, stacks shoot hot air up and away, but how do we know they're actually hitting strict safety limits?
The magic trick here is isokinetic sampling. Our nozzle has to perfectly mimic the exact speed of the exhaust.
Why? Because if suction is too hard or soft, inertia makes those heavy, sneaky particles totally miss the nozzle.
To pull this off, the pros use a specialized 4-part stack monitoring kit. Let's quickly break it down.
First up, an S-type pitot tube senses pressure drops to calculate the exact speed of those exhaust gases. Next, we carefully slide in a long thermocouple probe to check both the stack and the ambient temperatures.
Now, catching these pollutants takes totally different tools depending on if we're hunting invisible gases or physical particles.
Toxic gases bubble through chemical reagents in glass and pingers, while the solid particles get physically trapped inside filters.
A hefty vacuum pump does the heavy lifting, using rotometers to lock in that perfect, constant isokinetic flow.
Before we even start, plants must meet strict pre-test essentials, like having properly sized ports at 90-degree angles.
Once back in the lab, these collected filters literally bake at 120 degrees Celsius to remove excess moisture. Finally, we calculate the concentration. It's just the pollutant's total weight divided by the volume of sampled air.
But mistakes happen. Infrequent testing or uncalibrated gear leads to highly inaccurate data and massive fines.
To fix this, modern plants use continuous emission monitoring systems. This gives them real-time, completely automated pollution tracking.
150 milligrams per normal cubic meter. That's the super strict Central Pollution Control Board limit for particulate matter.
And it doesn't stop there. These strict baselines form comprehensive regulations governing other invisible, highly toxic gases too.
These limits are literally high-stakes laws. Following them prevents environmental ruin and keeps our ground-level air completely safe.
So, consider this final thought. How could optimized real-time stack monitoring change the very air you breathe tomorrow?